Reading the title, I bet you think I'm exaggerating, right? I mean, when we think of Antarctica, the first thing that comes to mind is an icy polar desert full of, well, birds and seals, essentially. Similarly, when we think of a rainforest, we might think of the Amazon, the world's largest tropical rainforest, famed for its biodiversity, and we picture it filled with a myriad of colorful species. Now, when we think of the different life forms in both those places, it's hard to find any real correlation. For many good reasons, you wouldn't find leopard seals in the Amazon, just like I doubt you'd see monkeys playing around in today's Antarctica. However, millions of years ago, these two worlds that are considered polar opposites today collided into one glorious place. Geographically, it was still Antarctica, but climate-wise, it looked rather different. This is also a fairly new discovery that isn't being talked about very much, which is why you might be unfamiliar with it, but it's true. 100 million years ago, the Cretaceous Antarctica was a tropical paradise. To better understand this phenomenon, let's go back a few million years, when most of Earth's landmass consisted of the ancient supercontinent Gondwana, which incorporated present-day South America, Africa, Arabia, Madagascar, India, Australia, and Antarctica. This supercontinent was fully assembled by late Precambrian time some 600 million years ago, and the first stage of its breakup began in the early Jurassic period, about 180 million years ago. Antarctica's section within Gondwana had a much milder climate than it does today, and it was located further north, closer to the equator. As a result, it was covered in dense forests and housed river systems, wetlands, and even warm coastal areas that teemed with life. The land's rich vegetation included early ferns, conifers, cycads, and other plant species which supported a variety of animals, including early dinosaurs, amphibians, and primitive mammals. During the Jurassic period, around 180 million years ago, Gondwana began to show the first signs of breaking apart. Tectonic activity slowly started pulling Antarctica away from Africa and South America. As the Jurassic transitioned into the Cretaceous period around 145 million years ago, the breakup process continued, and Antarctica started drifting southward. This movement not only contributed to isolation, but also began to influence Antarctica's climate, albeit slowly. By the mid-Cretaceous, Antarctica was still relatively close to equatorial waters and was far warmer than it is today. Even as the separation progressed, the continent remained lush and forested, featuring subtropical rainforests. These high temperatures that occurred during the middle of the Cretaceous are known as the Cretaceous Hothouse. The phenomenon is exactly what the name suggests, a hot greenhouse effect caused by increased carbon dioxide in the atmosphere. It's still not known for certain what happened in the Cretaceous era that led to these unusually warm temperatures in such an isolated area, because keep in mind that at this time, Antarctica had finally drifted away from Gondwana towards the South Pole and was its own landmass. However, there's a widely accepted theory that the mid-Cretaceous, in particular, had a much faster rate of seafloor spreading, and so more volcanic sources of CO2. This would have then created a greenhouse blanket warming up the land at a much higher rate than normal. Now, you might be wondering how we know for a fact that Antarctica was a tropical paradise when it all happened millions and millions of years ago. Many studies and observations have been made in the last decades regarding these claims, so let's focus on some of the more recent ones. Just a few years ago, in February 2017, scientists were shocked to find evidence of a swampy rainforest that thrived in Antarctica about 90 million years ago. They drilled a core sample from the ocean floor in the Amundsen Sea near West Antarctica and were quite surprised to see soil from an ancient forest, complete with fossilized plant pollen spores and a thick network of plant roots. The forest would have been located just 560 miles, 900 kilometers, from the South Pole at the time, yet the climate there was mild, much warmer than today. Now, there aren't many ways to explain this mild of a climate on a large landmass. It pretty much had to be a lack of ice sheets across Antarctica and high carbon dioxide levels in the atmosphere. Researchers estimate the average temperature was about 54 Fahrenheit, which is comparable to modern coastal forests. Let's get back to the findings. These same scientists found something unexpected in the core sample, a layer of soil from ancient land, not ocean. Needless to say, the team was surprised by the bright colors and unique texture of this sediment layer, buried 89 to 98 feet below the ocean floor. Using X-ray CT scans, the team saw a remarkably well-preserved root system with cell structures still visible. In the fine, silty soil, they found fossilized pollen and spores, including some from the earliest flowering plants ever found so far south. With these observations, the consensus was unanimous. This area had to be a rainforest, and from their perspective, looked like the swampy forests found on New Zealand's South Island today. To further confirm their findings, they compared the conditions in this ancient forest soil with those of plants in similar climates today. They also checked for clues in the soil about rainfall and temperature. It turned out this ancient rainforest got moderate rainfall, about the same as modern-day Wales, with a mean temperature of 54 Fahrenheit annually. So if you're watching this from Great Britain, just know that a few million years ago, Antarctica's climate was the same as yours. Summer temperatures averaged 66 Fahrenheit, and the rivers and swamp waters would have been about 68 Fahrenheit. I don't know about you, but this sounds like a very pleasant place to be in, and nothing like the frozen desert we have today. Another interesting finding from these temperatures was that according to their climate models, high CO2 levels were needed to create these warm conditions so close to the South Pole. While scientists had thought CO2 levels in the Cretaceous were around 1,000 parts per million, these conditions likely needed levels between 1,120 and 1,680 ppm. Cretaceous Antarctica. Being the vibrant and diverse ecosystem that it was, it of course supported a fascinating array of animal life. The dense temperate rainforests were home to various dinosaurs, including large herbivores like Antarctopelta, a type of nodosaurid ankylosaur known for its armor and defensive adaptations. Other herbivorous dinosaurs, such as Rabdodon, roamed the underbrush, foraging on the abundant plant life, which included ferns, cycads, and conifers. Among the carnivorous dinosaurs, small theropods like Matheronodon and possibly larger predators such as Carcharodontosaurus hunted for smaller animals, adding a layer of complexity to the food web. In addition to dinosaurs, Cretaceous Antarctica was also home to marine reptiles that thrived in the warm, shallow seas. Plesiosaurs, with their long necks and flippers, were common, as were mosasaurs, large predatory reptiles that could grow to impressive lengths. These marine predators preyed on fish and other marine life in the nutrient-rich waters surrounding the continent. Fossils of ichthyosaurs have also been found, indicating a diverse marine ecosystem typical of warmer tropical climates. Of course, the forests and wetlands also provided habitat for small mammals which were evolving during this period. Early marsupials, similar to today's opossums, could be found there, as well as the presence of early birds, such as Hesperornis, who adapted to life both on land and in the water. But this discovery of ancient rainforests on Antarctica is more than just a cool fact about our planet's past. It's a reminder of just how dynamic Earth's climate has been and still is. It's a story of how our planet adapts, shifts, and changes. And while it might seem like another world, these changes happen because of natural shifts in carbon dioxide, tectonics, and other factors. Things we're still dealing with today. And even though we know for a fact that ancient Antarctica was a tropical paradise full of life, there's still one big question left unanswered. How did the Earth cool down enough to bring back ice sheets to the poles? This is still an unanswered question that, if figured out, could bring us a whole lot of knowledge on how climate change caused by excessive CO2 concentrations can actually reverse itself. But that's a topic for another video. If you're interested to learn more about Antarctica's past, be sure to check out my recent video on ancient Antarctica's #1 apex predator. As always, thanks for watching, and until next time on PaleoPath,